In this video, I'm going to talk to you about how to graph an inequality. So when we graph an inequality, in this case, we have two variables. We got x and y. So we can't just use the number line anymore. We have to go to an x and y coordinate grid. So in this one, we have y is less than x plus 6. Notice that my graph goes by twos, so this would be 1, 2, 3, 4, 5, 6, okay? So if I were going to graph just if it was an equal sign, I'm just going to graph it normally. So it has a plus 6, that means I start at 6. 6 is the y-intercept. That's where it crosses the y-axis. It's also known as the zero term. And the slope, the number in front of x that we can't see, there's a 1 there. And so my slope is 1, and I can put a 1 over the number 1. So I have a rise of 1 and a run of 1. So I'm going to go up 1 over 1. Remember, my graph goes by twos, so up 1 over 1 is actually right in the middle. And I'm going to go again, 1, 1, up 1 over 1, up 1 over 1, up 1 over 1, and I'm going to go the opposite direction, 1, 1. Okay. And then when I look at this symbol, this says less than. Less than means we only want to include less than the line. We don't want to include the line. So when you have these symbols, this is less, this is greater. And if we had this one, this would be less or equal. This is where we would draw a solid line because we want to include the line as solutions. This is greater or equal. So our line is just less. We want our solutions to be less. So we don't want to include the points on the line. And the way that we would show that is we draw a dashed, I sometimes call this a dotted line, dashed, dotted, okay? So we draw a dashed line to show that those points are not solutions, but they do help us find the solutions. So we want less than this line. So if you were to put your hand on one side and your other hand on the other, the hand that's lower would be less. Or another way to do this is you want below the line. In this case, below the line is on this side. So all of the points in that region are going to be solutions. And in this case, the point 0, 0 should be a solution since it is in the shaded region. So the point 0, 0, we're going to check and make sure that really is true. So this is x, this is y. I'm going to plug in my x, well, the y and my x. 0 plus 6 is 6. And I have 0 is less than 6. So this works. 0, 0 works. And that's what we wanted to happen because 0, 0 is in the shaded region, which means that it must be a solution. I could go through and I could do 1, 1, and I could plug in any point in the shaded region and check to see if it works. I'm not going to go through and do that for all of them, but you can if you would like to. So you could also check 1, 1, you could check 2, 0, you could check 2, 2. So those are the points that are solutions. We're going to graph another one. So we have y is greater than or equal to negative 3x. In this case, there's no b value. There's no f0 or y-intercept. So that means, what number can you add to anything that won't change its value? That's 0. So we're going to start at 0. Again, my graph goes by twos, so make sure you realize that. And the slope is negative 3 over 1. So we're going to go down 1, 2, 3, and we're going to go over 1. So I'd have a point here. And we could go again. 1, 2, 3 over 1. 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 Okay, so here I've got my dots, and in this case it's greater or equal. So we do want to include the points on the line. Okay, so those would be solutions because we can equal to the line. And then from there it's greater. This symbol is greater. So if you put one hand on one side of the line, here's your hand. You can't see my hand if I put it there. And here's your other hand on the other side of the line. This hand is higher, therefore it must be greater. And in this case, we want to shade the greater, so we're going to shade everything on this side as solutions to the inequality. So I could pick a point again and check it. So maybe 2, 2 right here. And we could check to make sure that works. So if I put 2 is greater than or equal to negative 3, plug in 2. I'm checking the point 2, comma 2. Here's your x, here's your y. So I plugged in x and y. 2 is greater than or equal to, that's negative 6. So is 2 greater than or equal to negative 6? Yes, it is. So it's good that we have it shaded. Okay, we're going to do one more example. So in this one, we're going to start at 2. That's our y-intercept. And now my graph goes by ones. So see the change that's happened here. Our slope, rise and run. Rise is 1, run is 2. So I'm going to go up 1 over 2, which would be here. Up 1 over 2, other direction. Okay. And then it says that it's less or equal. Less or equal means we do want to include the line. We want to equal to these points. So to show that, we draw a solid line, not dashed. And less than is below. And again, if you want to put one hand on one side, one hand on the other, below is going to be the hand lower, which is going to be this one, this side of the line here. So in this case, 0, 0 is included. You could check that point. You could check this point. You could check any point you want to that is in the shaded region to see if it works. I'm going to check one. So let's do 2, 1. This point right here. 2, comma 1. Let's just make sure. So 1 here. And I'm going to plug in 2 for x plus 2. Half of 2 is 1. So I did a half times 2 and I got 1. And then 1 plus 2 is 3. So 1 is less than or equal to 3. And yes, 1 really is less than or equal to 3. So 2 comma 1 is a solution to that inequality. So we're going to come back for a minute and check if some points are solutions. So here I've got x and y. I'm going to plug in my x number and my y number just to see if they really are solutions. So 0 plus 0 is 0. And that's the greater than sign with 5. Is 0 greater than 5? No. So the point 0, 0 is not a solution. We're going to check this one, x, y. So negative 2 in for y. And 3 in for x. And if you multiply that out, that's negative 6 plus 4. Bring down the symbol, negative 2. Negative 6 and plus 4 makes negative 2. Is negative 2 less than negative 2? No, it is not less than negative 2. It's equal to it. So in this case, no. The point 3 comma negative 2 is not a solution. So let's go through and let's check the bottom one. Got to get rid of this. So we're going to plug in x and y. So 2, I'm plugging in x, 1 minus y, y is 2, the symbol, and 1. So I've got 2 here when I multiply. 2 take away 2, less than or equal to 1. Well, 2 take away 2 is 0, less than or equal to 1. Is 0 less or equal to 1? It could be one or the other. If it's less, it'll work. If it's equal, it'll work. So, since it's less, then yes, the point 1, comma 2 is a solution. Another way you could do this, just like number 2, if you were to go ahead and graph that, notice that you would start up at 4, then you go down 2 over 1, down 2 over 1, and you'd get a graph. Here you'd draw a dashed line, and you would shade below. Well, a way you could check is you could see if the point 3, negative 2, so you'd go over 3 and down 2, you could see if that point was in the shaded region. And if it is, then that would be a solution. If not, then it wouldn't. So this one, 3 comma negative 2, actually ends up to be right on the dashed line, which means it's not a solution. And that's all for graphing inequalities.